So again, an absolute value is the distance a value is from 0 on the number line. So for example, I could say, if I had the absolute value of 5, I don't know why I wrote that so small, it's this distance, right? 5 is 5 away from 0. The absolute value of 5 is 5. The absolute value of -5 would be measuring this distance, which is also 5 units. Right? This distance is the same as this distance. The absolute value of -5 is also 5. Distances are always positive, right? When I drive from my house to Westchester Community College, I drive 45 miles. When I drive home, I don't go -45 miles. Distances are always positive. I drive 45 miles again. So it's measuring a distance. That's why absolute values are always positive. So in this section, we're doing equations that have absolute value. So let's start with the simplest equation. The square root of x, not square root, the absolute value of x is equal to 5. Right? And it's going to say solve for x. Well, what value of x will give me 5? Right? Well, I know when x is 5, that'll give me 5. Right? The square root of 5 will give me 5. And I know when x is equal to -5, that will give me this result as well. So my solution for this problem is x is equal to 5 and x is equal to -5. Because both of those, when I substitute it back into the original equation, creates a true statement. Square root of 5 is equal to 5. I'm sorry, the absolute value of 5 is equal to 5. And the absolute value of -5 is equal to 5. This example is a little different. It's not very much different, right? In this example, this value in here is equal to 5, or this value in here is equal to -5. So I could rewrite this. I could say whatever this value is, right? It's stating it's equal to 5. So I could say x plus 1 is equal to 5, obviously. But since I have the absolute value here, it could also be equal to -5. Because if this was a -5 in here, the absolute value of -5 would also equal 5. So that kind of starts our procedure. Our procedure would be, first of all, we would isolate the absolute value. In this case, it's already isolated. And then we would create two equations with opposite answers. One positive, one negative. One plus, one minus. And solve and check. Solve each and check. So I'll give you a second. We could solve these and then plug it in and see if it works. -1, -1. I have x is equal to 4. -1, -1. I have x is equal to -6. I want to check these. I could substitute it in. 4 plus 1 is 5. The absolute value of 5 is 5. Checks. -6. And -6 plus 1 gives me -5. And the absolute value of -5 is also 5. So they both check. Easy problem. Let's try this example. Again, we want to follow the procedure. We want to isolate the absolute value. And then we're going to create two equations and solve each of them.
I think you're muted, Professor.
So I'm going to have to subtract 5 from both sides of the equation. So I'm going to have a 2x minus 3 is equal to 11. My absolute value is by itself, so I could create two equations. 2x minus 3 is equal to 11, and 2x minus 3 is equal to -11. Solve and check both. So I'm going to add 3 to both sides. And I'm going to get 2x is equal to 14. X is equal to 7. I'm going to add 3 to both sides. I'm going to have 2x is equal to -8. So x is equal to -4. Does it check? 2 times 7 is 14. 14 minus 3 is 11. 11 plus 5 is 16. That checks. -4. 2 times -4 is -8. -8 minus 3 is -11. Absolute value of -11 is 11. 11 plus 5 is 16. They both check. This next example, x plus 6 plus 5 is equal to 3. I put a little star here because this one's a little bit different, but you'll see right away. I'm going to subtract 5 from both sides. I'm going to get the absolute value of x plus 6 is equal to -4. And right here, I know there's a problem. Red flag. There's a problem here because I have an absolute value that's equal to a negative, and I know I can never have an absolute value that's negative. So this is not going to work. This is going to be a problem.
This is a -2.
-2, I mean. Regardless, we have an absolute value equal to a negative. It's going to be no solution. But let's follow through. Let's show that it's no solution. So I'm going to have x plus 6 is equal to -2. And I'm going to have x plus 6 is equal to +2. I subtract 6 from both sides of the equation. I get x is equal to -8. I subtract 6 from both sides of the equation. I get x is equal to -4. I substitute -8 in. -8 plus 6 is -2. The absolute value of -2 is 2. 2 plus 5 doesn't equal 3. -4. -4 plus 6 is 2. 2 plus 5 does not equal -3. So x equals -8, x equals -4. It doesn't check. There's no solution when you have a problem like that. So in this example, we want to isolate the absolute value. So I'm going to subtract 7 from both sides. So I'm going to have 4 times 1 minus 3/4 x is equal to 3. My absolute value is not by itself. I have this 4, which is attached by multiplication. So I want to remove it by doing the opposite. I'm going to divide both sides by 4. 4 divided by 4 is 1, so those are gone. I have the absolute value of 1 minus 3/4 x is equal to 3/4. My absolute value is by itself, so now I can create two equations. I'm going to write 1 minus 3/4 x is equal to 3/4, and 1 minus 3/4 x is equal to negative 3/4. I don't like fractions, nobody does, so we could get rid of these fractions by getting rid of these denominators. If I multiply everything by 4, then that would cancel out, and that would cancel out. So I have 4 times 1, which is 4, minus 3x is equal to 3. I want to get my x term by itself, so I'm going to subtract 4 from both sides. So x is equal to a positive 1/3. Negative divided by negative is positive. On this side, the same thing. I have fractions. In order to get rid of the fractions, I'm going to multiply everything by 4. 4 times 1 is 4. My 4's cancel out there, so I have 3x. My 4's cancel out there, because this is like 4 over 1. It's up high. It's negative 3. I want to get this term by itself, so I'm going to subtract 4 from both sides. I have negative 3x is equal to negative 7. I divide by negative 3. I get x is equal to a positive 7/3, which is awesome. These should always check, but we'll throw it back in. Oh, I want to do fractions. Let's throw it back in, make sure it checks. Oh, that is the original problem. No, that's the original problem. So let's make sure this checks. When you put in 1/3 here, right? If I put in a 1/3, if I do 4, 1 minus 3/4 times 1/3 plus 7, when I put in that 1/3 here, those 3's are going to cancel out. I thought this was going to be easier. Okay, those 3's cancel out. And I'm going to have 1 minus 1/4. And 1 I could write as 4/4 minus 1/4 is 3/4. The absolute value of 3/4 is 3/4. Those will cancel out. I'll have 3 plus 7, which is equal to 10. It checks. Over here, we do the same thing. We're substituting in 7/3. My 3's cancel out. So I'm going to have 4 times, what is this, 1 minus 7/4 plus 7. If you get confused here, remember, if you have two fractions and the denominators are the same, you could just add them. So I'm going to write that 1 as 4/4 minus 7/4. And that's where I'm getting my negative 3/4 from. And negative 3/4 in absolute value is really positive 3/4. And so really I have 4 times 3/4 plus 7. My 4s are going to cancel out. I have 3 plus 7, which is 10. That one checks also. So all is good with the world.